Good morning, class. Today we are on Saxon Book 4, Lesson 23, which is Lines, Segments, Rays, and Angles. Today is a lot of writing. So I have a bunch of definitions. We're going to talk about every single one of them, but really you need to get these down in your math dictionaries so that when you see these words in the future, you have something to turn to and pictures and examples to reference as you're like, what are they talking about? What does that word parallel mean? So we will start with lines. And you've heard the word line before. If you've been in school for any amount of time, you line up at the door. But the mathematical word line means a straight line like this that extends infinitely forever in both directions. That's what these little arrows here mean. That this line goes on and on and on and on until I run out of board space, and then it goes down across the parking lot and over across town forever and ever and ever, in theory. Now, has anyone ever drawn a line that's extended forever and ever? No. But when we're speaking about math and lines, that's what we mean, something that goes on forever and ever and ever. Typically, when we say a line, what we mean mathematically is a line segment. So a segment is just like a line. It's a straight line. However, it has a starting point and a stopping point, which are marked by these dots that are called end points. So this right here is an end point, and this one is another end point. Even though this one's at the beginning, it's called an end point. Okay? So when we say get in a line, what we're talking about is make a line segment, because there's going to be a starting spot and a stopping spot. Lines. Something that is very similar is called a ray, and this is the point of the year where I always make a joke about my family. Before I was teaching 3rd and 4th grade, I taught geometry at a high school, and this stuff is all over 10th grade geometry. You will see this again, 4th graders, again and again and again. But I always kind of laughed with my students because I was a geometry teacher and my husband's name is Align. It's not spelled like this, but that's how we pronounce it, Align. So geometry teacher married to Align, and Align's brother's name is Ray. So, take a minute to laugh about my family joke. But we have this type of line, not Mr. Duarte, but a line. We have a ray, which starts with an end point, and then it can extend in any direction. I just chose to draw it this way, and it goes forever and ever and ever in one direction, okay? Forever and ever, till the end. So make sure you've got line, segment, and ray in. I will move out of the way. You can pause here so that you can see the board clearly and get those written down in your math dictionary. The next two words we are going to talk about are parallel and perpendicular. So, two lines are parallel if they never ever intersect. They could be this close together, they could be this close together, but they're never going to intersect. So these two lines go forever and ever and ever, and they will never cross. That makes them parallel. One little trick I use to help my students remember parallel is if you spell parallel over here, notice the two L's. Those two L's are parallel line segments. So that can help you remember what parallel looks like. Not quite the opposite, but something that we usually compare with parallel is perpendicular. This is perpendicular. Perpendicular are lines or line segments which create 90-degree angles. So if you notice up here, a 90-degree angle is kind of a special angle. We give it a special name. We call it a right angle. And 90-degree angles are what you see in squares and rectangles. This, all four of these, are 90-degree angles. So if you've got perpendicular lines, they create this square corner. I'll get out of the way, make sure you get all of those in your math notebook, please. All right, so if you were here in my class, what we would do at this point is a little parallel and perpendicular activity. So I have you get your arms ready, and you're going to show me parallel like this. You can make fists or straight hands. It's up to you. But hold your hands, your arms, from elbow to fingertip as close to parallel as you can so that if they extended forever and ever, they would never intersect. So this isn't parallel. This is parallel. Not this, not this, not this. Parallel. Okay? Then we do perpendicular with our arms. So there's two ways you can do this. You can make the T, the cross here, that could be perpendicular, or you could just do this, because here we have one perpendicular line down at my fist and my elbow here. So, not perpendicular, that's not a square corner. Not perpendicular, that's too big of an angle. Straight up and down, and straight horizontal to the ground, perpendicular. Parallel, perpendicular. So once you have that down, I'm going to call out two words, either parallel or perpendicular, and I want you to show me with your arms. Do we have parallel or perpendicular? What does that look like? Ready? Let's start with perpendicular. You should look like this or like this. All right, parallel. Straight up and down. Or you could do this and have it be parallel horizontal. Parallel. Perpendicular. Perpendicular. Parallel. Oh, I went a little too far there. Parallel like this. Perpendicular. Parallel. Perpendicular. Parallel. If you want to continue that game at home with mom, dad, or a big brother or sister, you certainly can. But the important thing is for you to recognize what does parallel look like and what does perpendicular look like. Okay, we're not done with the definitions. Moving on, now that we've got all of those, I have just a few more here. These have to do with angles. So what is an angle, you ask? An angle is this space in between intersecting lines. This right here, this space, this area, that's the angle, okay? An angle is made up of a couple different parts. We have the vertex of the angle. That's the point where my two lines intersect. It's like the corner of the angle. And then the lines or rays or segments are called sides of the angle. So this is kind of anatomy of an angle here. And then today we're going to talk about two different types of angles. So the first type is an obtuse angle. When you say obtuse, what happens to your mouth? It has to open really wide, really big, right? Obtuse angles are really big angles. They've got a lot of space between the two sides, okay? Obtuse angles, mathematically, are any angle that is greater than 90 degrees. Remember, a 90-degree angle is that square corner. We call it a right angle. Obtuse is anything bigger than that. And I didn't actually write an example, so let me do that now. So, an obtuse angle here would be something like that, where this is the vertex, And we've got all that space in between my two sides. Okay? An acute angle. So here's my trick for that one. Cute. What do we think of when we think of cute? We think puppies, kittens, babies, small things, right? So acute angles are cute little itty bitty angles. They're so cute. Acute angles are smaller than 90 degrees. So this right here, that would be an acute angle. It's tiny, it's little, it's so cute. You might want to pause right now so that you can get all of these definitions in your math dictionary. And then we'll move on to some practice problems. Move you over here. Okay. So from this lesson, the types of things that you might see are they might draw some angles and ask you to describe them. So I have 3 angles here, and they want us to describe each one. So let's start with the middle one. See that little box? That box in the corner is kind of like your cheat sheet. That's your tip. Hey, it's a right angle because it makes a square corner. So this right here we would call right angle. So of the 2 that are left, which one's the sweet little cute acute angle? That would be this one. This space here is less than 90 degrees. So when I say degrees, let me write it. We write it just like we write temperature. 90 degrees with that little circle symbol. Degrees are what we use to measure angle. Each degree is a little tiny piece of space, and we use something called a protractor, which you'll be looking at a little bit later in this textbook. And the protractor tells you exactly how many degrees this amount of space takes up. So this one is less than 90 degrees because 90 degrees would be an L shape like this. So this one is acute. And which one's obtuse? That would be this big fat guy here. Obtuse angle. So we've described each of our angles here. Hang on, I lost my eraser. Okay. The next type of problem that you might see will give you a shape. This is just a quadrilateral shape. It is labeled T, S, R, Q. And they label shapes by putting letters in their corners, okay? So then this question says, identify each of the 4 angles in this figure as acute, right, or obtuse. So what they want you to do is each angle is labeled. This angle here is going to be angle T. So they would want you to write T, and what is T? What kind of angle is that? T is right. It's a right angle. You can say just right, or you can spell out angle. T is a right angle. I see another right angle in this shape. Do you see it? S. S is also a right angle. Okay, so we've done T and S. Let's look over here at R. What kind of angle is R? It's a big fat angle. It's much bigger than 90 degrees. So what would we call that? R is an obtuse angle. And finally, Q over here. What a cute little teeny tiny angle. Q is acute. There we have it. The next thing you might be asked to do is draw. So this one says, draw a triangle that has one right angle. So if you're asked to draw anything that has a specific type of angle, you want to draw that angle first. So I'm going to draw a right angle, and I put the little box in there to show that it's a right angle because I didn't use a ruler, I didn't use any kind of square, I just looked at it and figured it out with my eyes. So that box is math notation that says, no matter what this looks like, it's supposed to be a right angle, okay? And then it's supposed to be a triangle, so I have to make that side a little longer. Just finish it off. There's my right triangle. All right, so those are the types of problems you may see after completing this lesson. The next activity suggests that you look around your classroom. In this case, you're going to look around your home for these different shapes. Can you find anything that's parallel? Can you find anything that has a perpendicular corner? Can you find acute angles or obtuse angles? So look around your house, see what you can find, and say, hey, Dad, is this an obtuse angle? And see what they say. For additional practice, you can do the lesson practice problems. It has a lot of drawing. You know what? We can do this together, actually. If you look at lesson practice, or you can just listen to me read it. It's on page 144. So I won't be able to see yours, but I can show you what mine look like, and then you can compare it. So the first one, draw two segments that intersect. Remember, intersect means they cross, but are not perpendicular. So there could be a lot of different answers. Go ahead and draw yours while you're waiting to see mine. Intersect, but are not perpendicular. So they could look something like that. The only thing it's not allowed to look like is this, no square corners, because the problem specifically said not perpendicular. Okay, the second one says draw two lines that are perpendicular. So go ahead and put that on your paper. And then you'll see mine, and I'm going to put the little square corner in there to show that, yes, I mean for these to be perpendicular. And there's my example. You could have drawn it like this. As long as it still made a square corner, that's perfectly all right. All right, the next problem says draw a ray. You might want to look in your math dictionary, or I see that it's behind me on the board still, to draw a ray. A ray has an end point, and then it has one side that extends forever and ever, and it can be any direction you choose. So I made mine going down. The arrow here is the notation that says, hey, this is supposed to go on forever and ever and ever. Next problem. Are the rails of a train track parallel or perpendicular? How do you know? Well, a train track, we're talking about the rails of a train track. So I think what they're talking about is this. These two right here, the part that the wheels kind of choga on. So is that parallel or perpendicular? That's parallel. They will never ever cross. If they did, the people on that train would be in big trouble. I would not want to see crossing railroad tracks, not where one side crosses the other. It's different if you have, you know, something like this where two trains cross the same part of the track. That's okay. But I would not want to be on a train with railroad tracks that do that. Ugh. I think we'd fall off the track. Now, there's another part of the railroad tracks. They have the rails, but then, and I'm not really sure what these are called, crossbars or something. They have little pieces of wood that cross them like this, right? So if we were looking at that, what type of angle or what type of intersection do we call that? This right here with this right here, that makes a square corner, so that would be perpendicular. A triangle. Any triangle has how many angles? Think about what an angle is and how many of them do you see on a triangle? So the angle is the space up here. So there's 1, there's 2, there's 3. Did you know tri means 3, as in tricycle has 3 wheels? Triplets are 3 babies. Triangle means 1, 2, 3 angles. Okay, and the very last practice problem says, which of these angles does not look like a right angle? So we have that one. This is A. B looks like this. C looks like this. And D looks like this. Which one of these does not look like a right angle? Well, A, clearly a right angle. C too. But look at B and D. That's a tough call. So one way to look at it is to hold it so that one of the sides is horizontal to the floor and go, oh, nope, B's not a right angle. What about D though? If I hold it like that, oh, look, that looks like it could be a right angle. So our answer here would be only B. Which one is not a right angle? B. Ladies and gentlemen, have a lovely afternoon. Now is the time for you to work on your written practice, which starts on page 144 of your textbook. I will see you soon.